Howdy! In this video we're going to build a simple program where through the process of natural selection tiny cells will evolve and adapt to a changing environment. We'll start with a blank Python file and go to a tiny inhabited world. The aim of this video is to show how a bunch of simple rules can give rise to the process that contributed to all the variety of life on Earth. So, let's go. Let's create an empty window with Pygame. Now that we have some space to work with, and since our cells will be drawn as circles in the final program, let's try to render a single white circle right now. To do so, we need to pass 4 arguments into the drawCircle method. A surface on which we want to draw, in our case it's the screen, the color, the location of the circle center, and finally the radius. Great! All we need to do now is to automate the drawing process. Then we'll be all set to turn these static circles into tiny creatures. We'll use Python classes to make this trivial. Our class will be called Agent, mostly because programmers think it sounds cool. Each instance will handle its own rendering as well as inner logic that we'll add soon enough. In the constructor we'll provide position, velocity in both directions, and the color. The last 3 will be the entire genome of an organism. It is also a good time to import the random module, to randomly nudge the inherited velocity for when we implement reproduction. Let's make our agents actually do something. To make them visible, we'll use the already familiar drawCircle method. To make them move, we'll just update the position using cell's velocity each frame. And that's it! Now let's create a list of agents, iterate through it every frame, and see how it goes. Well, if we ignore the fact that all of them are monochrome and spawn in the corner of the screen, it works. Okay, it should work properly now. Wonderful! With them more or less resembling something living, we can finally implement the logic that will make them evolve. Right now our cells are just moving around, so let's give them the ability to split after they have lived for a certain amount of time. During our loop, we need to check if the current cell is old enough and return 2 new cells in case it is. Otherwise, we skip it. Replication in real life is imperfect, but thankfully our code already accounts for that in the constructor. The children now inherit all the parameters of the parent cell, and like in real life, they may differ a bit. Let's check if it works as intended. Now, the last 2 things we need to add before it all falls together are selection pressure and death. After thinking for a bit, I have decided that we can introduce a sort of wind to the world that will push all the agents in some direction. We can use the mouse offset to decide the direction and the strength of the force. And finally, during our update loop, we can squeeze in a check for if the cells are within the bounds of the screen. If they are blown away or go out on their own, they die. And just like this, the program is complete. The agents are born, they move, and if they happen to withstand the wind long enough, they procreate and the cycle repeats again. For our last change, I will add a line to show the wind direction. Let's see what we have. Now, while the model is quite simple, we can already observe some real biological phenomena with it. For example, all this time we've had a gene for color, but besides looking nice for us, it is completely irrelevant for survival. It maps quite well with the concept of neutral mutations though. And funnily enough, we have already been using them in the same way people use them in real science. We can track what organisms are related and when they have approximately diverged from their common ancestor. Speaking of the color once more, we can also use it to observe population bottlenecks happen in real time. If the wind changes at a faster rate than the species can adapt, lots of unique colors will get completely lost. While living things are quite resilient, the speed of change of the environment itself matters a lot. Should the environment shift too quickly, life goes extinct. Thanks for making it to this point. Feel free to experiment with the code yourself, I'll leave the link in the description. I would also appreciate it if you liked this video and left your thoughts in the comments. Next time we will be translating images into waves, so if you'd like to see that, consider staying. Bye.